This is a rock, specifically quartzite. It's plentiful, it's cheap, and frankly, it's pretty dumb. Its biggest accomplishment so far is sitting on the ground. And this is a central processing unit, a CPU. It's the brain of your computer, your phone, and the smart TV that needs an update every single time you want to watch something. It performs billions of calculations every second. It is arguably the most complex object humanity has ever created. But here's the joke, they're basically the same thing. The only difference is about 3 months of insane engineering, dangerous chemicals, and a process that looks a whole lot like magic. Today, I'm going to show you how we trick a stone into thinking. The journey begins here. Sand. Sand is mostly silica, silicon dioxide. It's the second most abundant element in the Earth's crust, which is lucky for us. But B sand is filthy. It's full of impurities, and we need pure silicon. For that, we take quartz gravel and blast it in an electric arc furnace at over 2000 degrees Celsius to separate the silicon from the oxygen. But pure isn't pure enough. We need electronic grade silicon. It has to be 99.99999% pure. Well, there's 7 times 9 after the decimal. If you have even 1 alien atom for every billion silicon atoms, the whole thing fails. So to get that purity, we use Sokolsky process. I know the pronunciation is hard. Bruh. And now we dip a tiny seed crystal into molten silicon and slowly, very slowly twist it out. The result is a single giant, perfect crystal ingot. Think of this ingot like a stick of high-tech salami. We slice it into thin discs called wafers. These are polished until they are smoother than a mirror. Now we enter the clean room. This place is thousands of times cleaner than a hospital operating theater. If you sneeze in here, you'll probably bankrupt the company. A single speck of dust is like a Godzilla to a microchip. So, how do we draw billion parts circuit onto this? Well, we don't draw, we print. It's called photolithography. It's basically a very expensive version of stencil and spray paint. We coat the wafer in light-sensitive chemical called photoresist. Then we blast it with extreme ultraviolet light through a patterned mask. Where the light hits, the chemical hardens. We wash away the soft parts, and boom! We have a pattern printed in silicon that is thousands of times smaller than a human hair. Right now, we have just pretty patterns. But silicon is a semiconductor. It's kind of at conducting electricity. We need to give it an identity crisis. We do this by doping. We bombard the wafer with different atoms like boron or phosphorus. These impurities change the electrical properties, creating areas with too many electrons called n-type or too few called p-type. By arranging these n and p-type next to each other and putting a control gate on top, congratulations, you have created a transistor. Now look, I'm massively simplifying things here. If I explain the actual quantum mechanics of electron tunneling, this video would be 4 hours long and we'd all be crying. Just know this, it's a switch. The gate lets current flow, symbolizes 1, or blocks it, symbolizes 0. Repeat this process a few dozen times, and you build these 3D structures. Great, we have billions of switches, but they are currently socially distancing. They are not connected. We need wiring. This is the interconnect layer. Imagine building a 100-story highway system on top of a city, but the roads are microscopic strands of copper. We deposit insulation, ash trenches, and fill them with copper, layer by layer. If you unravel the wiring in a modern chip, it will stretch for miles, which is impressive, considering the whole thing fits on your fingertips. Now, the wafer is done. But does it work? Not yet. We use a massive probing machine to test every single chip. The bad ones are marked for the trash, then a diamond saw slices the wafer into individual chips called dies. This tiny square is the CPU, but it's naked and fragile. We can't just jam this into a motherboard, it would break immediately. It needs armor. This is called packaging. We mount the die to a green circuit board and glue a metal heat spreader on top. This protects the chip and keeps it from melting itself into a puddle of very expensive sand when you try to run Cyberpunk on it. And there it is, the finished CPU. Wow. It started as this rock And through light, heat, and enough math to make your head spin, we rearrange its atoms to create something that can think. Isn't this fascinating? Well, thanks for watching. If you want to know how we actually teach this rock to do math, binary code, and logic gates, let me know in the comments. I'll see you in the next video.